Now that we've defined subsets and practiced writing a few subsets, we want to explore the idea of how many subsets can a set possibly have? Because earlier I was saying up here, whenever we were talking about this set B, notice I wrote three different subsets of that set, and I said you could continue and write many, many more. So how would we know how many are there? How many subsets of that set actually exist? Because there are several. So let's explore that idea by starting with set R that only has one element, the number 8. So let's write down all of the subsets we can think of to that. So any subset of this has to have any set I write down to be a subset of this, any element in it has to also be in R. We know by definition that the empty set is a subset of every set, so I can always write down the empty set. And then for this one, the only other set that I can write down is another set that just has the element 8 in it, because 8 is in this new set and 8 is also in R. And that's it. So if we have a set with one element in it, we can get out two subsets. And I'm going to write that over in our chart here. And I'm going to write it over here to the right hand, to the right hand side. Now, if you have the empty set, if you have a set that's empty, the empty set is always a subset of itself. So let's do one example up here that wasn't here. If our set, I'm going to call it A, is the empty set, the only subset of that would also be the empty set, because again, by definition, the empty set is a subset of every set. So if you have no elements in your set, there is one subset of that, and that would be the empty set again. Okay, what about the set P with the elements Sue and Bob? Let's write subsets of that. Well, we would have the empty set by definition. We could have the set that just contains Sue. We could also have the set that just contains Bob. And we could have the set that contains Sue and Bob. And that would be it. So if our set has two elements in it, there ends up being 4 subsets. Okay, what about the set that contains elements A, B, and C? Let's write all of the subsets to that. So again, by definition, the empty set is a subset of that. We could write down the set only containing A, the set only containing B, the set only containing C, so all of those would qualify. And then we could have, what about the set that just contains A and B only? That would work. Each of those elements are also in W. So would the set that just contains A and C. That would work. And so would the set that just contains B and C. That would also work. And then there would be one final set that could be a subset, which is, W itself. So the set of A, B, and C would also count. So that is 1, 2, 3, 4, 5, 6, 7, 8. So what I hope we've done at this point is established a pattern enough to figure this out for any number of elements. So we have 1, 2, 4, 8. And I can see what's happening here. Every time we add an element to the original set, it doubles the amount of subsets. So if I continue in this manner, if I have a set of 4 elements, I'm going to have 16 subsets. And if I have 5 elements, I'm going to have 32 subsets. Okay, now I could do times 2, times 2, times 2 until I get up to 12 times to figure out if I have 12 elements in a set, how many subsets will it have, but that would take me a while. And certainly what we want to establish is a formula here. What may or may not be completely apparent at this point is that all of these number of subsets values are all powers of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So we've established now a formula. In order to figure out how many subsets there are to any set, you take 2 to the power of whatever that number of elements is. So if I have a set with 12 elements, I would have to take 2 to the 12th power to figure out how many subsets there are of that set. And if you take 2 to the 12th power, you will get 4,096 subsets. I would not want the task of writing all of those out. Right, so we've written out all of the subsets if we have 1 element or 2 elements or 3 elements, but these grow exponentially. So once you get above 3 or 4 elements, you really aren't going to want to write them all out. You're going to want to just know this formula to know how many of them there are. So the formula then is 2 to the n power. So that's what we're going to write down here. If a set has n elements, then there are 2 to the n subsets of that set. And if you want just proper subsets, right, then you're going to have to always omit that very last one, that one that is the set itself. So if there are n elements, then there are 2 to the n subtract 1 proper subsets there.